Talking about interior angle sum. So what is the interior angle sum of a triangle? 180. So we know that we've proven that in the past. We did a little math to show that every triangle always has 180 degrees, and we've used that in other situations. To solve for missing angles or help us solve exterior angles, we were able to use this knowledge of 180 degrees. So based off of this knowledge that we know of triangles, we're going to use this and we're going to take it to help us figure out what is the interior angle sum of a 4-sided shape, or a 5-sided shape, or a 38-sided shape. So that's going to be our goal for today. All right, so how can we try to find the interior angle sum of each of these shapes? So we have a 4-sided rectangle and a 5-sided pentagon. Do you know any of those angles? Not really. What was that? Okay, we can bust out a protractor. But let's start with that. What do we know about interior angle sums? What shape do we have the interior angle sum for? Triangle. We know the triangle is the interior angle sum of 180 degrees. So that's our one piece of information we have. We need to use that to help us. So you want to try to break it into triangles?
No.
You don't want to try to break it into triangles?
No. I want to break it into triangles.
How many triangles can we break this quadrilateral into?
No.
How?
Straight down the middle.
Like this?
No. I mean, yeah.
Angle to angle? So I have two triangles. What's the interior angle sum of each of these triangles?
180.
So this is 180, and this is 180. So if I put that together, what's my total interior angle sum?
360.
360. So any 4-sided shape should have the interior angle sum of 360 degrees. Pretty cool. What about this pentagon? Can I break this into triangles?
Heck yeah. The top.
Straight down the middle?
No. Yeah.
But is that a triangle?
No, there's a section more. Oh, just kidding. No. I said the top. Do more sections. The little top. Yeah, that's the other side. Other side. There's one, and then down the corner side.
Middle.
Yeah.
How many triangles do I have?
3.
This is 180, this is 180, and this is 180. What's 3 times 180?
420. 80. I think. Darn it. 440.
540.
420. Like my number's over.
Okay. So, we were able to cut each of these up into smaller triangles, and we were able to add all of those up, all the triangles up, and that gave us our situation. So let's see if we can use this one more time, and see if we can try something a little bit harder. What about a 9-sided shape? Can we do the same thing for a 9-sided shape and still work?
Pizza. Cut on pizza. Triangular pizza.
I don't know.
Pizza's triangular.
So something like this. So let's talk about this first. Interior angle sum. That's all of our angles added together, right? And so if you cut it like a pizza, you would get all of these angles. But what also are you adding?
A center dot.
You're adding in
Oh.
all of these angles as well. Are those technically part of our interior angle sum?
I guess
Not quite. So we can't use that method. It's a good thought. That's what a lot of other students try to do as well. But we can't quite use that for interior angle sum.
Just put it down the middle.
Put it down the middle like
Now add
that.
point.
Point to point. Okay.
the
Like
points-
this.
Not across from each other.
There ain't none across from each other.
Yeah, there are.
No, there ain't.
Not directly, but there.
Like this one.
How do you want this, Elise? See if we can
Or this one.
Diagonal don't work.
Yeah. From one point, go to the other. Yeah. How do you want this?
So all of the other points? Okay.
That's, yes.
So we split up into a bunch of triangles. How many triangles do we have?
we still have,
1, 2, 3, 4, 5, 6, 7.
although we do have more.
So we have 7 triangles. They're not all the same triangles, but we know that it doesn't matter what the triangle looks like. That triangle is always going to have 180 degrees as its interior angle sum. So we can do 180 times 7, and that should give us 12.
1,260.
Okay.
Are you kidding me? Oh, I was guessing.
I 7 times 180. I thought that was right.
But diagonals were. Sign me up for quiz bowl. Wait.
Okay.
You wanna get one?
So we were able to cut that up using that same method, and we got 1,260 for our angle. Now, what happens if we had a 38-sided figure? So wouldn't you have to want to draw all those triangles in them and count all those triangles and multiply by 180?
That would
Seems like a lot of work.
accurate.
I do, it sounds easy.
How many sides do I have on my first shape?
2.
How many triangles do I have? So 4 sides, 2 shape, or 2 triangles. What about the second one? How many sides do I have?
Oh, the sides divided by 2.
So, well, how many sides do we have?
6.
5. And
Crap.
how many triangles do we have?
3.
3.
Crap.
Okay.
So,
How many sides do we have?
8.
9. We
God.
have 7. So we subtract by 2, and then multiply that by 180. That seemed to work.
Sides minus 2. There you go.
So for any shape, as long as it's a convex shape, which means it doesn't have any like points or any like things going outside of it, or any angles that are larger than 180 degrees, this should always work. So the interior angle sum of any shape is the number of sides minus 2 times 180. So however many number of sides we have, subtract 2 from it, multiply by 180, and you're done. It's a very simple formula, very easy to use, and we're going to look at some situations where it can be helpful. If I can, right up on the board. So it's n minus 2 times 180, and this is always equal to your interior angle sum. So put it into practice. Let's say we have a 17-sided shape. All we have to do is place 17 in for n, so 17 minus 2 times 180, and then we can find our interior angle sum. So 17 minus 2 is 15, 15 times 180.
is it gonna get any more complicated than this?
We'll see some other situations.
600. I got all these stuff.
So for the most part, it's very simple. It's just using that formula. But we're going to use it backwards, and we're going to look at some other situations where you might have to do a little bit extra work, but the main basis, the main standpoint is just that quick and easy formula. But we will build upon that a little bit. So we have 2,700. See if you can do a 38-sided shape. In that same formula, see if you can figure that out. Quick and simple.
6,400. Hey.
So what did you do, Amanda?
38 minus 2.
38 minus 2, and that gives you,
6. 36.
okay, and
Times it by 180.
you ended up with
6,480.
6,400. Good. So very simple, very easy, quick formula. Much easier than like having to do like the Pythagorean theorem.
Thank you, John.
I created this in math just for you.
Thank you.
Discovered it myself.
That's what
All right. So that's our easy interior angle sum formula. Pretty easy, throw in your number and you're good. But now, let's think about this backwards. So we can use it one way. Let's see if we can use it the other way. So let's say rather than having the number of sides, I have the interior angle sum, 1,980, and I want to find how many sides it has. So rather than starting with the sides, that's what I want as my answer.
Once you divide it,
That's 13 sides.
What were you thinking, Colton?
once you divide it by 2,
Divided by 180.
yeah,
So we know that 1,900 180 equals our number side minus 2 times 180. So in order to solve for that n, our number of sides, we can divide by 180, like you said. So dividing by 180, that gives us 11. And then from here, add 2. So n equals 13. So we can use it either way. If you know the number of sides, you can find the interior angle sum. Or if you know the interior angle sum, you can find the number of sides. You just have to think which way you need to use it, whether you need to use it straight or whether you have to go backwards. What was that? Yeah. All right. So see if you can do that exact same thing. So you have an interior angle measure of 4,140. See if you can do it backwards and see if you can find the angles or the number of sides. I'm sorry. I'll pause it while you do this. All right. Someone walk me through what they did. Alex?
I took my 4 big numbers.
4,140.
Yeah, and I put it, like I said, equal to n minus 2 multiplied by 180.
Okay.
I divided both sides by 180. Took the quotient thing and added 2. Yeah, that.
What does it turn out to be?
23.
All right. Thank you.
Oh yeah, I did number. Right, yeah, and then added 2 on to that. And then 5.
Good. Okay. Do we have any questions over this? No. So it's pretty simple. We can do it straightforward or we can do it backwards, just depending on where you start or what you're looking for. If you're looking for number of sides, you would need the interior angle sum. If you're looking for interior angle sum, you would just need the number of sides. But other than that, it's always going to be 2 and 180 in there. That's not going to change. So some things that might affect it some things that might change depending on what you're looking for and how you can use this problem on other types of shapes is depending on what that shape, or what type of shape that is. So we have 3 situations that some shapes might fall under. Not every shape is going to be under one of these, but these are some types of special shapes. So equilateral is a type of special shape. Equilateral, we typically think about equilateral triangles. What do we know about equilateral triangles? All the sides are the same. So equilateral shapes have all those same sides. So an equilateral pentagon would have every side on that pentagon being the same. Equal angular is exactly how it sounds. Equal angular. So it has equal angles. And so all of the angles in that shape are always going to be the same. So if you have an equal angular hexagon, all 6 sides on the hexagon, all 6 angles on the hexagon are going to be the same. Doesn't necessarily mean that side lengths are going to be the same, but the angles. And then regular. Regular is the most common one. This is the one that's going to come up most often, most frequently. It's both of these put together. So it has all of the same angles and all of the same sides. And so regular shape is the one that you see most common. An equilateral triangle has all of the same sides, but also all the angles are 60 degrees, so technically that's actually a regular shape. So it should be a regular triangle, but we call it an equilateral triangle. Just because it's nice. But regular shapes are pretty frequent. A square is a regular shape. All the angles are 90 degrees, all the sides are the same. So regular shapes come up pretty frequently. They're your common shapes that you see. Or they're the ones that you draw when you try to draw a shape or something. Like draw a hexagon, you're probably going to draw a regular hexagon. It's just a way to think about it. But with regular shapes, we can use this formula and we can expand on it just a little bit more to help find specifics. For example, so I have a regular 15-sided shape. So I know that all my sides are going to be the same, all my angles are going to be the same. I want to find out what each specific interior angle is. Not just the total, but each specific one. So what are our thoughts about this? It's regular. So what does that mean again? All the sides are going to be the same, and all the angles are going to be the same. So I know all 15 of these angles in here are going to be the same thing. They're all going to be the same measurement. Now, how can I use that to my advantage? So we can find one and times it by 15. That'll give us our interior angle. But we just want to find one of those things. That's all we are looking for. But can we use that information? Can we use what you thought backwards? So you said find 1 times 15, and I'll give you your interior angle sum, right? Can we find the interior angle sum and then use that to find our single value? So you said if we find 1 and multiply it by 15, that'll give us the total, right?
Yeah.
So let's think about that backwards. We're looking for just a single value. That's what we want to find. That's our answer. It's just finding a single one. So if we find the total and then split it into 15 equal pieces, will that give us 1? So let's try that. So how can we find the total of this? How can we find the total interior angle sum of our shape?
Angles are in there. -2 times 1.
So we can take 15, subtract 2, times 180. So 15 minus 2 is 13. Go on to do 13 times 180, which I don't know off the top of my head. 13 times 180 gives you 2,340. So all 15 of these angles added up is 2,340. Now we know they're all equal, so we can split it equally into 15 pieces. So we can take this whole thing and divide it by 15. And that leaves us with 156. So each specific angle is 156 degrees. Now 156, is that a large angle or a small angle? It's a pretty large angle. When we are dealing with triangles, we typically have something double digits. We wouldn't get too many things larger than 100. We sometimes did, but we typically wouldn't. Why do you think it's larger?
You got a circle.
So the more sides we get, the closer we get towards a circle, the rounder our shape gets. And so we were doing, so on the last problem we had a 38-sided shape. So if we tried to draw a 38-sided shape, you're gonna have to draw like a ton of little tiny lines in there. And it's gonna look pretty close to a circle, right? So the closer you are to a circle, the more round your shape is gonna be. So that means the wider your angles are gonna have to be. What number is pretty close to 156? That's special.
180.
180. So 180, what type of angle is that?
I don't know. That's 90.
180 angle is just going to be
Straight.
a straight line, or a linear angle is what we called it, I think, in the past, or a straight angle. And so it makes a straight line. So we can't have a straight line, because a straight line would just be a line. It wouldn't be a shape. But the closer you get to a circle, the closer you are for all these angles to be 180 degrees. And so a 38-sided shape, I think if it's regular, all the angles are somewhere around 170 degrees. So it's going to get pretty close to 180, but they'll never surpass 180. So that's something you can think about when you're solving one of these problems. If you're solving a problem that has 49 angles on it, and you get somewhere between your angles are all 22, 22 seems pretty small. And so you can kind of use that to gauge your answers. If I have a lot of angles, I should be closer to 180. If I have less angles, I should be smaller numbers. So you can use that to sort of help evaluate yourself when you go through these problems. See, even 15 sides has already 156 for every side. So okay, kind of help. Are we okay with this problem and how we solved it though? You just took the total interior angle sum and divided it into 15 equal pieces? I think that's it. All right. What do you notice about these problems? All my angles are not the same, and all my sides aren't the same. So I know it's not an equilateral, equal angular, or regular triangle, or sorry, regular shape. It's none of those. What else do you notice?
None of them are the same.
None of them are the same.
You can't make a triangle out of those.
What was that?
You can't even make a
can.
triangle or?
Yeah, you can.
Yeah.
Yeah, no.
Colin, do you want to make a triangle out of it?
Oh wait,
Yeah.
I want to make one on the other
Out of
one.
the left one or the right?
I don't.
Do the right, I'll do the left.
Oh, I got the left.
Darn it.
So make a triangle for me out of all those.
Fine. Over. Okay. Well, I guess you can. But
So-
they don't have to take one.
What was that?
They don't have to take one. But every
Every triangle always has a equal 180. It doesn't matter what the shape of the triangle.
It says 117. Wait.
So 117 is cut in two pieces.
Okay.
It's only part of it's going in here. Only part of 112 is going in there. So it technically, you don't know what those values are at the moment, but it does work. So one sort of strategy of cutting any shape into triangles, pick one point on that shape, and draw an angle towards every other one except for the two adjacent ones, and then always cut them in a triangle. So I can pick this one, and I can draw an angle to every other spot, and it'll always cut me into triangles. We did the same strategy on the 9-sided shape. Picked one spot, and drew one to every other spot, and it splits it off. It does look like a seashell. So as long as it's a convex shape, which means it doesn't have any angles that are larger than 180 degrees, or every angle is less than 180 degrees, you can always split up into a triangle. So it will work great in that shape. But how are we going to solve for x, or solve for y in our second case? How can you go about that?
You need your triangles. Al, why'd you erase it?
So what do we need the triangles for?
See how many sides you got.
there. Yeah, and then you can see, yeah, put those back. So then, wait, then why is there a cover? So divide 112 by 3
How do you know they're all three equal pieces though?
Because they all add up to equal
112 is the point of all three.
But how do you know each of these angles in here are the same? Because this one looks a little bit smaller than this one over here.
Well, you just know.
You just know this is true. All right, so we do use the triangles. The triangles helped us find the interior angle sum. What is the interior angle sum of this shape?
180.
So how many sides do I have?
Oh gosh, I have 5.
So 5 minus 2, it's a pentagon, times 180. We already did this one. This one gave us 540. So I know all of these angles in here add up to equal 540.
540 divided by 1, 2, 3, 4, 5. Yeah.
Well, are they all the same though?
Oh, no.
So if they're not all the same, I can't divide it, because dividing splits me into equal pieces.
Minus. Like subtract all the other angles, whatever you have left.
So I'm just going to subtract what I know,
Yeah.
and I'll leave you with what I don't know. So we did the same strategy when we were solving for missing angles in a triangle. We'd take 180 minus the other two angles, and we'd get our missing angle. So it's the exact same thing, we're just dealing with larger shapes now. But it's the same strategy. So we can take 540, subtract 100, then 112, then 113, and then 117, and we get 98 degrees. And that is your missing angle.
Wow.
So as long as you know all of the other angles, except the one you're missing, or have at least some information on that, you can find that missing piece by subtracting what you do. So see if you can do that exact same thing. See if you can solve for y using that same method. Find out the interior angle sum, subtract what you know to get y by itself. So for that second problem, we saw it was another 5-sided shape. So we knew the total was going to be 540 once again. Any pentagon always has 540. We can subtract all those values of 135 minus 88 minus 112, and then we can't forget that right angle in there, so that's going to be 90. And so our total should have been 105, 115? 115, I'm sorry. There you go. And so 115 was our missing angle y. So as long as you know all those other ones, subtract them away and you're good from that interior angle. 35. Alright, so we're going to do one last problem, and then we will call it a day. What do you notice about this problem on the left?
Arrows.
So the arrows just are pointing, so x plus 11 is supposed to be in this corner, 123 is supposed to be in here, 102 is supposed to be in here. It's just with the size of the shape, it's hard to
There
exactly
is a
move that.
problem.
There is a problem. What is the problem?
There are parentheses. X plus 11. We don't know what X is.
All right, so we don't know x's. How many x's do we have?
11. 2.
So we have this x plus 11, and then we have this x. So there's two x's. Because they're both x, because they're both the same variable, we can assume they're the same number. So we're going to try to solve for x. How can we go about that?
Can't we just plus 11 at the end? Combine the like term.
So, but they're separate angles.
Combine the
We do
angles.
want our thing all over again, like the subtract
Wait,
and whatnot, but
is
it's like on
X
the
one
end,
or
you
two?
can get.
Wait, not.
But is A the same angle as the other side?
Not necessarily. We don't know that. It might look the same, but we don't know. That's a good thought, though. Alex, what were you saying?
Like you do like the thing that like you just did with all like the like subtracting everything like on the end. And then like once you get your x, then like you put your x, and then like when you get the x plus 11, add 11 on the x.
Okay, let's see what that takes us. So, how many sides do we have on this shape? 1, 2, 3, 4, 5, 6, 7. So 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 should be 900. So 900 are interior angle sum. Now what should we go, how should we use that? What should we do next?
Subtract all the other numbers from 900.
Let's subtract what we know, and so we're left with what we don't. So let's subtract 102, 161, 165,
And then subtract 11, and then what that is divided by 2.
123. So if we subtract all of that,
Because there's 2 X.
we should be 223, I think. 221. 221. So we found the interior angle sum, subtracted everything we did know, all of those other angles in there, cross them out, and we are left with 221. So 221, this equals x and x plus 11. So those two added together.
I said it never really would.
So that's two angles added together. A single angle by itself can never be over 180. What can we do from here?
Like
Divided in half.
We can combine our like terms. So we have two x's, so that's 2x plus 11 equals 221.
Minus 11.
So get rid of our constant. So subtract 11. That gives us 2x equals 221 minus 11 is 210.
Yeah, and then you just divide by 2. I was right.
And x equals 105. So this x up here is 105. So Colton, they're very close to 102, and they looked very similar, but just because our naked eye isn't a protractor is not perfect, we can eyeball it and assume it's going to be close to that, but we can't always assume. And then our last one is x plus 11, which is just 116 as our angle. Okay. So even though you might be missing multiple angles, you can still use this method to help you solve. Find your interior angle sum, subtract what you know, and then set up an equation. Set up equal to what you don't know, and start combining like terms, getting rid of your constants, getting rid of your coefficients, and you should be good. Any final questions for today? Alright, we're going to continue this a little bit more tomorrow, and it will show up on your Friday assessment for next